Okay, Bismillahirrahmanirrahim. Inshallah, now we'll do 5.8, which is like what happened in 5.7. 5.7, it's just only substitution, but we are concentrating about the log rule. Now we're concentrating about the inverse trig functions. I know the integral of this is arc sine u over a. Integral of this is 1 over a arc tan. Integral of this is this. Actually, to do that, they need only, we know that dx, for example, the arc sine, square root 1 minus x squared dx, that will be sine inverse x plus c. Using some substitution, we can get this one. We can get this one, I mean. Yeah. Okay. So let me just apply the rule. Dx over this. Here my a square is 4. So I will let a equal 2. So this one will be sine inverse x over a plus c. That's it. That's mainly the idea. So as I said, I have a equal 2 in this case. Okay. This one, part B, I need to manipulate it a little bit. I need to make it in this format. For sure, it seems to be like in this one. So the coefficient of a or u square should be 1. So what I will do, I'll take 9 out. Then I have x squared plus 2 over 9. Okay, so I have 1 over 9 outside. Just a number. Dx over x squared plus, I will write this as what, square root 2 over 3 all square. So what is my a? Square root 2 over 3. Now it's very clear. So now I'll apply this rule. That will be 1 over 9. 1 over a, 1 over square root 2 over 3, which is 3 over square root of 2. Tan inverse. This is what? U over a. U is x, and a is, it will be 3x over square root of 2. 3x plus c. So the answer is 1 over 3 square root of 2 tan inverse 3x over square root of 2 plus c. Okay. This one the same idea, but I'm using now sec. So I need this to be 1. So I have integral dx x. I can take 2. This will be square root x squared minus 9 over 4. Yeah, let me do it in steps. Okay, that will be dx x square root. I take 4 common factor. I have x squared minus 9 over 4. That 4 will go outside as 2. So 1 over 2 outside. X square root x squared minus 3 over 2 square. So this is my a. So it will be in this format. So the answer is I have half outside. 1 over a, that will give me 2 over 3. Secant inverse, absolute value of x over a. So that will be over 3 over 2. So that will be 2 over 3 plus c. Oh, plus c. No difference. No, it will not make a difference. That will be 1 over 3 secant inverse 2 absolute value of x over 3 plus c. Okay, let me do other problems. Yeah, this one is tricky a little bit. The idea is we'll do what? I multiply by x in the numerator and the denominator. That will make no difference. However, it will make a big difference. Now, if I let u equal e to the power x, so du is what? Ex dx. So this integral will be what? Will be integral du over u square root u square minus 1, which is what? Which is just the secant inverse, where a equal 1. So that will be secant inverse of u plus c, which is secant inverse ex plus c. That will be the answer. Yeah. This one, I think I need to split it into 2 parts. This one is easy one, just substitution. Yeah, for this one, let u equal 4 minus x squared. Du will be minus 2x dx, multiplied by minus 2 and minus half. So the integral will be minus half u is minus half du. And that'll give me what? That will give me minus half, add 1 times 2, u to the power half, plus c, which is minus 4 minus x squared, or minus square root, minus square root 4 minus x squared plus c. This one, I think we need the sine inverse. So, yeah, if you look at these things, yeah, it's very clear. It's like this one, where a equal 2. So it will be 2 sine inverse x over 2 plus c. Yeah, 2 is part of the question, but this is, and this one is sine inverse x over 2, which is just we are following this formula, where a equal 2. 2 squared is 4. Okay, so the answer is minus square root 4 minus x squared plus 2 sine inverse x over 2 plus c. Yeah. Okay. Now it comes to completing the square. Yeah, sometimes it's not written down. The denominator, which is this one or that one or this one, or not written in the right way, or in the nice way where I can apply the rule. I need to complete the square. We know what's the idea of completing the square. If we have x squared plus bx, yeah, x squared plus bx plus c. And that to make it, to complete the square, I need to add half the coefficient of x all squared. So I have x squared plus bx, half of this square plus c. I add something, I subtract it. So I'm getting x plus b over 2 all square. Now this is a complete square. If you open it, it will be x squared plus, plus b over 2 times x, which is b over 2 all square, plus the rest. Okay. So this is what's called completing the square. Okay, like this one. Yeah, this is the coefficient is 1. It will be easy, but the coefficient is not 1. You took it as a common factor. So I will take 2 just to apply it. I have 2x squared minus 8x plus 10. I take 2 as a common factor. What's the remaining? X squared minus 4x. And this is plus 10 outside. Now to complete the square, I will add half coefficient of x squared. Half 4 is 2 squared plus 4. I add plus 8, so I subtract 8. Need to be sure that 2 times 4. Huh? So that give me what? 2x minus 2 squared plus 2. So that will be the completing the square of this one. Now I wrote it as in terms of with the completing the square. Yeah, this one. Now the coefficient is negative. So your first step, you take minus as common factor, have x squared minus 3x. I add half of this squared, add 9 over 2. Since I'm adding now minus 9 over 2, so we'll add 9 over 2 outside. So that will be minus x minus 9 over 4, sorry. So this is 9 over 4. Yeah. So that will be x minus 3 over 2 square plus 9 over 4. So this is the completing the square. This is what they meant by the completing the square. Okay, let me do it in a problem. That will be what? Dx. I have x squared minus 4x. Actually, I need to complete the square for this. Rewrite this one. So that will be x squared minus 4x plus 7, which is x squared minus 4x. I add what? Half of 4 to squared. That will be 4. I add 4, I subtract 4. That will be x minus 2 squared plus 3. So that make the denominator as what? X minus 2 squared plus 3, which is square root of 3 squared. Okay, so if you look at the formula, it will be similar to this formula, where I have, let me write the formula in front of me. I have du over a squared plus u squared. That will be 1 over a tan inverse u over a plus c. So very clear, a is square root of 3, and u is x minus 2, and du equal dx. So there's no need for a fraction, so everything is ready. So, yeah, well, the coefficient if x is 1, it will be easy to deal with. So right away, this one I can write it. So now this is a, I have it, u is there, and du, there is no need for any, yeah. Yes, let me apply this substitution applied here. I have what? Du over u square plus a square, which is ready now. That will be 1 over a tan inverse u over a plus c. And that will be 1 over square root of 3 tan inverse x minus 2 over square root of 3 plus c. And that will be my answer. This is the way to deal with it. Yeah, this one, same idea. And you want it from this to this. Okay, so I want to find the integral of this from 3 over 2 to 9 over 4. First, I know 3x minus x squared is what? We did it before. Yeah, it's here. This one is this one. 3 over 2 squared minus x minus. So that will be 3 over 2 squared minus what? X minus 3 over 2 squared. Okay. So I have what? You have 3 over 2 to 9 over 4 dx over square root of 3 over 2 square minus x minus 3 over 2 whole square. Yeah, also we need to notice that, yeah, what is the formula? The formula is du over square root a square minus u square. That will be sine inverse u over a plus c. Okay, so I let u x minus 3 over 2. So du equal dx. So what will be that? That will be du over square root of a square minus u square. Okay, and now 3 over 2, that will be 0. Yeah, that will be definite. Infinite, that will be definite. So 9 over 4 minus 3 over 2 is what? 9 over 4 minus 6 over 4. That will be what? 3 over 4. Yeah, that will be 3 over 4. So that will be what? Sine inverse u over a. And a is what? 3 over 2. So that will be 3, and this is 2. From 0 to 3 over 4. That will be sine inverse of what? Half minus sine inverse 0. And the answer is pi over 6. Okay. That's it. That's it. Yeah. Okay. So sometimes you need to complete the square. These are quick ones. Yeah, this is secant inverse. This is we put 2 on outside half. That will be half integral. It lets u equal x squared minus 1. So du equal to x dx. So that will be du. U is minus half du. So it will be half times u to the power half plus c. So it will be square root x squared minus 1 plus c. Okay. This is you cannot do until now. That will do later. Here the same idea. A is easy. Let u equal ln x. Du equal dx over x. So I have du over u, which is ln absolute value of u, which is ln x plus c plus c. B, let u equal ln x. Du will be what? Dx over x. So I'm getting what? U du, which is u squared over 2 plus c. So it will be ln x squared over 2 plus c. Okay. Yeah. Also this one, easy one. As I said before, I have 9 plus 16 x squared. I want to make the coefficient of x squared 1 so that we can apply the rule easily, or I can let u equal this. So what I will do, I take 16 common factor. What we have x squared plus 9 over 16. So that will be 3 dx over 16 x squared plus 9 over 16. This is 3 over 16, I can take it outside. So I have dx. So now it's very clear. This is ready now. So it will be 3 over 16 times 1 over a, 1 over 3 over 4, so it will be 4 over 3 times tan inverse x over 3 over 4, which is 4 over 3 plus c. So I'm getting what? 1 over 4 tan inverse 4x over 3 plus c. And that will be the answer. Now let me do all the example problems. Okay. Now very clear, if I let u equal e to the power x, du will be what? Ax dx. So this one will be what? E to the power 0, which is 1, e to the power ln square root of 3, that will be square root of 3. I have du over 1 plus u squared. That will be tan inverse of u from 1 to square root of 3. Tan inverse square root of 3 is what? Pi over 3 minus pi over 4. That give me pi over 12, which it has. Okay, let me do all the example problems. Yeah, we have some old exam problems, not that much, but I think they can explain the idea. They give us a picture what was going on. Okay, now this one I can rewrite it. I can take t common factor. I have 1 plus ln t square from 1 to e. Now I let u equal ln t. Du will be what? dt over t. So this one will be 0 and e. This will be du. So I have 2 over 1 plus u squared du. You can take 2 outside, and this will be tan inverse of u from 0 to 1. Tan inverse of 1 is pi over 4. Tan inverse of 0 is 0, so that will be pi over 2, which is this one. Okay, this I will split it into 2 parts. I have x, 3 plus x squared dx, which is substitution, minus integral 1 over 3 plus x squared dx. This is 2.5. So I have half ln x squared plus 3. And this one is the tan inverse. And a is what? This is square root of 3 all square. My a is square root of 3. So it will be minus 1 over square root of 3 tan inverse 1 over square root of 3x, I mean, over square root of 3 plus c, which is this one. Oh, which is this one, sorry. Which is this one, yeah. Square root of 3 should be. Okay. This one I can take 25 common factor in the denominator. I have w square plus 4 over 25 dw. So I take 1 over 25 outside. Let me write this as w square plus 2 over 5 square. So that will be what? 1 over a, that will be 5 over 2 times tan inverse 5x over 2. X over a, yeah, from 0 to 25. From this is 0 to 2 over 5, not 25. And yeah, from 0 to 2 over 5, sorry. That give me what? 1 over 10 times tan inverse of 1, which is pi over 4, tan inverse of 0, which is 0, minus 0. So that give me pi over 40. Yeah, you let u equal x square. Du will be what? 2x dx. That make it what? 0.5. I put 2.5 outside. So that will be half du over square root 1. X to the power 4 is what? X square all square. And I put 2x square, it will be 1 minus x square. That will be sine inverse. Don't forget the half of u from 0 to half. That will be half pi over 3, pi over 6. Half is sine inverse is half. Sine is half. That's pi over 6, and that will be pi over 12, which is this one. Here, let u equal sine x. Du will be cosine x dx. So you have integral du over 1 plus u square, which is tan inverse of u plus c. So it will be tan inverse of sine x plus c, which is this one. Okay. Okay. We'll do the usual trick. I multiply by ex in the numerator and in the denominator. See what will happen. I'm getting what? Ex dx. I have e to x plus 1. Okay, now I let u e to the power x, du will be e to the power x dx. So I have e to the power 0, 1, the square root of 3, du over u square plus 1, which is tan inverse of u from 1 to square root of 3. That will be pi over 3 minus pi over 4, which is pi over 12, which is this one. Okay, I split it. X over 3 plus x square minus 3 over 3 plus x square. This is an integral, and this is another integral. Yeah, I have 2.5. So it's half ln of this minus 3. This will be square root of 3 square minus 3 times 1 over square root of 3 tan inverse, not tan inverse. It's still tan inverse x over square root of 3 plus c. This one is what? Half ln x squared plus 3. 3 over square root of 3. Don't forget 3 over square root of 3 multiplied by square root of 3 over square root of 3. That will be square root of 3. So that means square root of 3 tan inverse x over square root of 3 plus c, which is this one. E to the power t, tan e to the power t. Yeah, you think it's, yeah, actually it's not related to 5.8. This is an easy one. This is e to the power t tan et minus e minus t dt. That's it. This one, I let u equal et. So I have what? Tan u du, which is ln secant u plus c, which is ln secant et plus c. This one, it just e minus t plus c. So the answer is ln secant et plus e minus t plus c, which is this. Seems to be complicated. It's not. E minus 1. 1, if I do one trick, 1 plus t. This is 1 plus 2. I can take it as a power. That will be ln t plus 1 dt. Okay. Now, if you let this is to be u, du is 1 over t plus 1 dt. So I have what? 0, ln 1 is 0, that will be 1. E minus 1 will be ln e1, 2. I have, this is dt, du. So I have du over u. That will be ln of u from 1 to 2. And the answer is ln 2. Okay. Yeah, I think we did something similar. Is it the same? Yeah, the same. Actually, by 12. No. It's 1 over square root of 2. That's 1 over 2. Yeah, there's a difference. Okay. So I let u equal x squared, du equal to x dx. So I need 2.5 outside. So that will be half integral of du over square root 1 minus u squared. Since this is x squared all squared. Okay. Now the limits 0 and half give me 1 over 4. So this is half sine inverse of u from 0 to 1 over 4. So it will be half sine inverse 1 over 4, which is this one. Okay. Yeah, this one, how to do it. Yeah, this is ready actually. It's in this where u equal x minus 1, du equal dx. So this is du over 1 plus u square, which is tan inverse of u plus c, which is tan inverse x minus 1 plus c. Okay. Yeah. This one, if I let u equals square root x minus 1, what will be du? Or what will be, I can do this trick to find it. U square is x minus 1. So 2u du equal dx. Now rewrite everything. That is 2u du over 9u, okay, plus u cubed, which now easy to do. That will be 2 du over 9 plus u squared. Now it's ready. So that will be 2 a, this is 3 squared. So this is my a, 1 over 3 tan inverse u over 3 plus c. So that will be 2 over 3 tan inverse. What's my u? square root x minus 1 over 3 plus c. Okay, square root of x over 2x plus 4. How to do that? Yeah. If I let u square root of x square root of x over 2x plus 4. Yeah. Okay. 0 to 2. It's equal square root of x, u square equal x. So 2u du equal dx. So I have what? Yeah, I have this from 0 to square root of 2. Okay, square root of x is u. Dx is 2u du. This is 2u squared plus 4. Yes. So that will be what? 0 to square root of 2. This is 2u squared, 2 with 2. I have u squared over u squared plus 2, du. In other words, this is what? 0 to square root of 2. Let me do this trick. That will be 0 square root of 2, u, okay, minus 2 over u squared plus 2, du. Not u, 1. This is 1. U squared plus 2, that will be 1. So that will be u minus 2, my square root of 2 squares. This is my a, 1 over square root of 2 times tan inverse x over square root of 2. This is from 0 to square root of 2. That will be what? All of this. That will be square root of 2 minus 1 over square root of 2. Tan inverse of 1, which is pi over 4. Okay. And with the 0, it will be 0, tan inverse of 0, 0. That will be 2 over square root of 2. Not, this is 2 over square root of 2, sorry. Times pi over 4. Okay. Minus 0. 0 tan inverse of 0 is 0. So that will be what? Yeah, 2 over square root of 2 times square root of 2, square root of 2. That will be square root of 2. So I can take square root of 2, come back to 1 minus pi over 4. It's a matter of calculation. Okay. But this is the trick. You plug here, you get this one, which is either you can do it by the long division or by this trick, plus minus. Okay, this is long division. That gives me x. So I have minus 4x plus 4. So that will be x plus minus 4x plus 4 over x squared plus 4 dx. Okay. This one I can split into 2 parts. Actually, this is x dx. Actually, it's 3 parts. Plus integral minus 4x over x squared plus 4 dx. Plus integral 4 over x squared plus 4 dx. Am I right? Yeah, x cubed plus 4x. Minus 4x, 4 minus 4x. Okay. And to be sure about the calculation. So this is very clear, x squared over 2. Yeah, this is from 0 to 2. Yeah, everything from 0 to 2. So this is x squared over 2 from 0 to 2. This one, I can do it this way. can make 2 and minus 2 outside, which is minus 4. So this is du, and this is minus 2 ln x squared plus 4 from 0 to 2. This one is what? 4. This is 2 square over 2 tan inverse x over 2 from 0 to 2. Okay, that give me what? 2. This one give me what? 8. It will be plus minus 2 ln 8 plus 2 ln 4. Okay, this one plus 2 tan inverse of 1 pi over 4 minus tan 0. Okay, so I have what? 2 plus pi over 2. This one is what? Plus 2 ln 8 over 4, which is ln 2. So that I can rewrite it as 4 plus pi over 2. And this is minus, huh? Yeah, it should be minus. Yeah, I take minus 2 minus 1 common factor, or minus 2 common factor. The remaining is ln 8 minus ln 4, which is ln 2. Ln 8 over 4. 8 over 4 is 2. That will be minus 2 ln 2. Which is this one. Okay. 2 to go. Instead of doing completing the square, I add 1 and make 2 plus 1. So that will be dx over x plus 1 square plus 1. So it's tan inverse x plus 1. A is 1. And this is x plus 1, where I have dx equal du. So plus c. So this is the answer. Okay, last one. Yeah. If I let u, yeah, I can take a square root of x common factor. The remaining is what? The remaining is 1 plus x dx. Will that help? Okay. Do the same trick. Let u equal square root of x. U squared equal x. 2u du equal dx. So you write everything. That will be 2u du over. Forget this. Let me do it here. That will be square root of x, which is u, plus u squared x. U squared u. X is u squared, not u squared u. That will be 2 du. Take u common factor. That will be 1 plus u squared. So it's 2 tan inverse of u plus c, which is 2 tan inverse square root of x plus c. And that will be the answer. Yeah, didn't come here. Yeah, where we did many problems related to these inverse trig functions, which will give me some idea about 5.8. Mostly they are just substitution, but sometimes you need to be careful. Let me stop the recording. Yeah. Thank you.